So, our horizontal translations of a function shifts the graph of the function left or right without changing its size or shape. So our value of and sign of b determines the amount of direction of the horizontal translation. So for the function y equals f of x, when we have our horizontal translation, we have y equals f of x plus b, translates the graph horizontally along our x-axis. So we're moving it along our x-axis. We replace our x with x plus b in the equation of a function, translates our graph horizontally. So if b is greater than 0, then the graph is translated to the left by b units. If b is less than 0, it translates the graph to the right by b units. So our horizontal translation changes the x values of our function. Our first example here, we want to know what is the relationship of fx equals log base 2 of x plus 5 to fx equals log base 2 of x. So our log base 2 of x, that is our parent function. Okay, and then we are translating it to get our log base 2 of x plus 5. So what we will have is that f of x equals our log base 2 of x is horizontally translated 5 units to the, which way do we think we're going? The left. Okay, so if it's positive, it goes to the left. If it's negative in there, it goes to the right. It does the opposite of what we expect it to do. Goes to the left to get, or to become, f of x equals log base 2 of x plus 5. So what you want to be making sure that you use is the horizontally translated 5 units to the left, okay, to telling us what is going on. So, for example 2, with example 2, what we have, the graph of y equals x minus 4 all cubed. We are translating that 6 units to the right to find the equation of the transformed function. Now, they don't have the word horizontally translated in there, but we know that it's moving horizontal because it's asking us to go to the right instead of going up or down, which would be vertical. So our original function is our y equals x minus 4 all cubed. Now, to horizontally translate at 6 units right, we are picking up our graph and we're moving it to the right. So when we are moving something to the right, what we have to do is we have to substitute in a minus 6 in for our transformed function. So our transformed function is going to become y equals x minus 4 minus 6 all cubed, because that then gets us y equals x minus 10 all cubed. So what we have with this cubic, because it's cubed, that's what type of function we're dealing with, right? Originally it has its x-intercept at 4. We want to move it to the right by 6 units so the x-intercept becomes 10. Does that make sense? That's why we're minusing 6. Okay. Any questions with our first 2 examples? Okay, example 3, we have the point Q, which is 3 minus 4, on the graph of y equals f of x minus 4, is the image point of P, which is xy, on y equals fx. We want to find the coordinates of P. So what we have is that this point Q is the image okay? So that is on our graph of y equals f of x minus 4. And what we're trying to find is we're trying to find the point P on our original graph. So this one here is our original. This one here is our transformed. Okay, so we're going from our transformed back to our original. So what we have is that our y equals f of x minus 4 is horizontally translated 4 units to the, okay, so from our original graph, it has been moved, 4 units to the right. But we want to go back to the original, so we want to go back 4 units to the left to get our original function y equals f of x. Does that make sense? So it's the opposite of what has actually happened. So what we have is we have our point Q, which is the point 3 minus 4, and we want to go and get point P. Now, we are going to do something to our x coordinate because we're horizontal. Horizontal means our x coordinate, and we just want to write in our minus 4. Now, what I want you guys to think about is if we were to draw an axis, okay, so our y and our x, minus 4, whoops, that's okay. So if we have the point, our original point 3 minus 4, it could be here, right? Oh, why is my pen not working? So that's our point 3 minus 4, and that's our point Q, correct? Now, we want to move that to the left by 4 units. So if we're moving that to the left by 4 units, we want it to become over here, and what will the point over here become? It will be -1, -4 at point P. Does that make sense? See how drawing a little image makes sense in your brain? Because this is where so P is our original point. It was then translated to become Q, but we're going from Q back to P. So in order to get to P, what we have to do is we have to get -1, we have to minus 4. Does that make sense? To get P is going to be -1, -4. Now, horizontal translations are tricky to wrap your head around and to make sure you're getting correct. That's why we like to draw a little image off to the side. Okay, so my P was my original point. To get to Q, it was transformed and moved to the right because of the -4. So to get back, we've moved it to the left. Okay, it will make more sense as you practice it. Okay. Oh, we have another one. So, that's the same question. Nope, it's different. Okay. So this is the same, but I want you guys to have a go at this one now. We just have a different function. So we still have the point Q, which is 3 minus 4. It's on the graph of y equals f of x minus 2 is the image point. So this is the same setup. So the point Q, 3 minus 4 on the graph of y equals f of x minus 2 is the image. Okay, we have our point P of x on y equals f of x. I want you guys to have a quick go at seeing if you can do this to find the coordinates of P. I'll give you about a minute and then I'll start talking. Okay, I've quickly just written everything down. So y equals f of x minus 2 is horizontally translated 2 units to the left to get y equals f of x. So what we have is our point Q, and we're now moving it 2 units back to the left to get our original point. So when we move it 2 units back to the left, we're at this point here, which is 1 minus 4. Would that be correct? So we're going to have the coordinate 1 minus 4. In order to get 1 minus 4, we have to minus 2 from our original point. Cool? All right, turn the page for me once you've copied that down. Okay, so what we're going to do is we have the graph of y equals f of x is shown, and it is transformed into y equals f of x minus 3. We're going to sketch the transformed graph. So what we have here is we have our y equals f of x. On this same axis, we're going to sketch the transformed graph y equals f of x minus 3. So y equals f of x minus 3 is horizontally translated. What have we done? From y equals f of x to get to that, we've moved it to the right. By 3 units. So minus means right, positive means left. Okay, so we're moving it to the right by 3 units. That means we're going 1, 2, 3. So that first point, so our point minus 1, 0, right, is going to become minus 1 plus 3, 0, which is 2, 0. Does that make sense? Now, our other coordinates are up the top here. So our other coordinates are negative 3, 4, right, where they've put the little points in. And so that is going to become negative 3 plus 3, 4 is just 0, 4. Okay, and our other coordinate is 1, 4, which becomes 1 plus 3, 4. So that is going to be the point 4, 4. Okay, so we can put in our points in there. 2, 4, 4, 0, 4, and then we need to draw a nice smooth parabola. That's dodgy. No, nope. Where'd that line come from? That's not too bad. Okay, and that is y equals f of x minus 3. Does that make sense on how to do that? Yeah, so we're looking at the key points that we were given. So we were given the point minus 1, 0, minus 3, 4, and 1, 4. Is this our last one? No. Damn. Okay, the next one that we're going to do is we want to sketch the graph of y equals the absolute value of x minus 4. So what we have here is we have an absolute value graph. So we have that our parent curve is y equals the absolute value of x. Now, when we sketch our curve y equals the absolute value of x, it looks like a V. Now, I haven't provided any numbers on this, which is fantastic. Yeah. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, minus 1, minus 2. Okay, so our curve y equals the absolute value of x minus 4, oops, straight line, no curve, has been horizontally, goodness gracious, double L translated, horizontal. From y equals the absolute value of x. How many units have we moved? 4 units to the right. Okay, so if we need rulers for this. What that means is we are drawing if we were to draw our original curve in, it looks like this. You don't need to draw the original curve. I'm just going to do it to show you what happens. But you can draw it in a different colour if you would like. Okay, so this is our curve. Y equals the absolute value of x. And what we're doing is we're picking it up 4 units to the right. And so now it will look like so. Okay, and obviously we draw arrows at either end because it will continue on. So it has moved to the right. Okay, it'll be a nice V going both sides. Any questions on that? Okay, our last example. With our last example, what we want to know is what is the equation of y equals g of x in relation to y equals f of x. So what we want to do is we want to see how our f of x has been moved to become g of x. So have we moved our g of x to the right or to the left? To the left. Okay, so we have that g of x, y equals g of x, is how many units to the left have we moved? 3. To the left, I'll just zoom in, to the left of y equals f of x. So what that means is that g of x is equal to f of x. Now we're going to the left, so when we move to the left, we have a plus in there. So it's going to be plus 3. Okay, so therefore g of x is equal to, it's pretty simple, f of x plus 3.